Hello everyone and welcome to another Tech Tuesday on Fusion 360. My name is Brad Tallis and I will be talking about 3D printed threads. Stuff like this, and I'm going to show some examples and some tips and tricks. Now I'm going to start out by saying I'm not a professional on this. This is just my personal experience doing 3D printing. So there might be other ways, might be better ways. If you know of any, absolutely please share them in the chat or in the comments of our live stream. I wanted to give a shout out to Jason. He's helping me out today, answering the questions on the chat. So if you have any comments or question, Jason will be out there to help. If you didn't catch his live stream, I think he did one last week on kerf. I highly recommend watching that. And then another plug, we mentioned we were going to do some more cam live streams for all of you, and we are going to do a 4-part series where I'm going to actually design a part in Fusion, and then I'm going to pass it off to my buddy Angelo, and he's going to show how to create the manufacturing part of it, like the tool paths, etc. Then we'll do a session on collaboration. And then finally, we're going to go to Pier 9 and actually physically manufacture the part that we designed. So it's going to be a 4-part series. Let me share my screen with you real quick so you can see that real quick. To find that, all you have to do is go out to our Fusion 360 main page, and under Learn and Support, and this will bring up a page here, and if you click on YouTube, it'll bring up a link to all of our upcoming live streams. In fact, you see this one we're in right now, and I'm going to scroll down just a little bit. Actually, it looks like they're up here now. So you can kind of see the design to manufacturing, part 1 of 4, part 2 of 4, etc. So I highly recommend watching those, setting the reminders for that 4-part series. Okay, so like I mentioned, I'm going to talk about threads, and not just 3D printed threads, but just threads in general in Fusion 360. So for example, I have this 3D printed nut and just a part of a thread here. And you'll notice that it threads in beautifully. In fact, there's like no slop whatsoever. I cannot get over with how perfect this works. And why does it work so well? I'm going to show you some tips and tricks with that. So the first thing I'm going to do is, let me jump into Fusion. And I'm just going to start by creating a quick sketch. And I want to create a 1/2-inch diameter bolt, for example. So I'm going to start by just creating a circle. And I'm going to make this 0.5 in diameter. So I type in 0.5, I'll say okay. Let's go ahead and extrude this guy up. And let's just go, in this case, I'm just going to go like 1 inch, for example. Okay. Under the Create menu, we have this Thread command. And when I click on Thread, I can go ahead and select this cylinder. Now watch what happens when I do this. So you'll watch what happens over here. When I click on this cylinder, it actually figures out the closest manufacturable thread. So for example, in this case, I'm in inches, but if I were to millimeters, this would probably show up as, a metric thread type, for example. You can see that it determined that a 0.5 is about the closest. And then we have different designations. So you can kind of see we have, 1/2-inch 12 UNS, 1/2-inch 13 UNC. So I'm going to go ahead and do this 13 UNC, and you'll see that this preview updates. Let me go ahead and change it to something like 20. You can kind of see how that updates. Now, if I were to say okay right now, this is just a decal. It's just a sticker, basically, a representation of threads. Now, why would we want to do that? Well, when you have complex designs that might have lots of threads, you wouldn't want to have all of those modeled, but you might want to show that those are threaded rods, for example. So we use this kind of almost like an image. However, if I were to come over here and say make and try and 3D print this, all I would get would be a cylinder because there's physically no threads there. Okay. I'm going to go back into my thread feature in my timeline. Again, I'm ANSI unified, half inch 13, but you'll see right here it says modeled. If I click on that, it's going to physically model the threads. Now, by doing that, we've added a lot more edges, a lot more faces, and this is what I was talking about earlier. If we had a lot of these in our design, it could potentially slow down our session of Fusion. So, actually model the threads only on the ones that you really need to have modeled. Okay. So I'm going to do that again. I'm going to, this time, create a sketch on that plane. I'll do another circle here. Let's just do a half inch. And then I'm going to use a cool command in here called Polygon, circumscribed polygon. Okay. What this allows me to do is I'm going to go ahead and start in the center, and you can see that it's going to basically create a polygon that's circumscribed around the radius of our circle here. So now I can make this nut whatever size I want. Let's just say 0.4 in this case. And I'm going to go ahead and just hit enter, and you can see it created a 6-sided polygon. Now, I like, the anal retentive part of me, I like to have this horizontal, so I'm going to come in here and say horizontal, and I'll just click on that top edge, and you can see how it rotated it to be horizontal, and we are done with our sketch. I'm going to go ahead and turn this body off. Let's go ahead and extrude this up. And let's just go maybe 0.375 in this case. I'll say OK, and I'll turn this body back on. Now, if I were to section through here, we're going to see an issue. So I'm going to say section analysis, and let's just slice through. And you can see that sure enough, I have the threaded rod, but the nut itself is not threaded. So let's go ahead and do the exact same thing. I'm going to say create a thread. Notice the size is set to auto, designation set to auto. I'm going to go ahead and click on that circle, and check this out. I'm going to undo so you can kind of see this. Watch the size of the circle when I do this. Oops, I meant thread, not coil. So watch the size of the circle. As soon as I click on that circle, you see that it actually got smaller. And that's because Fusion is smart enough to figure out how to make it the drill size ready for the tap. So it does all of that for you. So again, half inch. Now I want to make sure I'm doing the half inch 13. And again, I'm going to say modeled because I'm going to 3D print that nut. I'll say OK, and we now have this nut. Let's go ahead and turn this back on again, and I'm going to section through it. Okay, so something like this. Now here is what I really like about Fusion 360's threads, is you'll notice that there's a bit of clearance in here. And at least on my 3D printer, this seems to be the perfect amount of clearance. Like I showed on this guy, this is pretty much the exact same example. I didn't do any modifications or anything like this, and I wish you could feel how perfect this is, but it literally just screws in very easily, and there's absolutely no slop. And the reason I'm pointing this out is because I'm going to do the exact same thing, but this time I'm going to import some models from McMaster-Carr. Okay, so let's go ahead and come under Insert, McMaster-Carr, and I'm going to make this a little bit bigger. I'm going to click on screws and bolts. I really like how McMaster-Carr has this set up. I can scroll down here and let's just do, you know, a 1/2 inch 13, for example. Let's do the hex head screw, and I'll do maybe like 1.25 inches in this case. Okay. I'll click on this product detail. Anything that has this little CAD symbol next to it means there's a 3D model available. Actually, even more than 3D models. There's drawings, 3D models, etc. So I'm going to just say save. And it's going to bring in the McMaster-Carr one, which I really like because, you know, you can even see the markings on it. It's got the cool chamfers, etc. Whereas in my example, I just did one really quick, not that exciting, right? So let's do the exact same thing. I'm going to insert another McMaster-Carr component. This time, let's do a 1/2 inch nut. Let's just do a hex. And let me scroll down here just a little bit. I'll do a 1/2 13. Do the exact same thing. I'm just gonna, here's a drawing of it. We're gonna save it as a step file. And I'm gonna pull that out over here so we can kind of see it's in the wrong orientation. But I can fix that really easily. So I'm just going to kind of rotate this around. And I'm going to cheat. I'm going to do this point to point. I could create a joint and all that kind of stuff, but in this case, I'm just going to hover over this face. And you can see I can grab this little center point right here. So I'm going to click on that center point. And then I'm going to do the same thing over here. I'm going to hover over this face. And I'm going to grab that center point. And just that quickly, I was able to move the nut where it needed to go. Okay, so let's go ahead and turn on our analysis again. And obviously, they're not lined up, so I'm just gonna drag this over really quick. Let me just kind of look at it from the front view. And I'm just gonna sort of line up these teeth, just kind of as a visual right now. Now this is what I wanted to point out. Notice how tight, I can't really use my arrow, notice how tight those tolerances are compared to what we get over here. So my first tip is I personally like using Fusion's thread command. Now I am going to show you how you can bring in McMaster-Carr components and put Fusion's threads on there. That's the next thing I'm going to show. But if you just bring in parts from like McMaster-Carr or maybe from a customer's site, you might want to do a sample print first before you print the big huge object or whatever you're going to do. I might try printing one of the nuts or the bolts from that particular customer and see how well does it fit, and do we actually have to modify it. So that's my first tip. Okay. Now I mentioned that you can actually modify these. So let me go ahead and talk about that. So I'm going to turn off my analysis and let's just turn off this nut. So here's my McMaster-Carr bolt that we brought in, and I really like it. However, I want to basically recreate the threads on there. So I'm going to select basically the faces that kind of define the thread. So I'm going to grab those faces there. I'm going to go ahead and grab this face here. And then finally, I'm going to grab this inside face. I'm going to have to zoom up a little bit. So you can see I grabbed all of the threads except for this outside one. Okay. Then all I have to do is say delete, and you'll see that it turns it back into a cylinder pretty quickly. So that's using the direct modeling techniques. Now I can come in and say, let's go ahead and do a thread. I'll click on there. Again, it recognized it as a 1/2 inch. Let's do 1/2 inch 13, modeled, and boom, we're back to having a threaded part that's attached to my McMaster-Carr part. So, and I could do the exact same thing with the nut. So I'm just going to come in here, grab a couple of these faces. So I'm going to grab that guy there, that one there, and the, let's just say this inside, let me do, let's see, do this guy here. Okay. I might rotate around, make sure I get all of those thread faces like so. I'm just going to hit the delete key on my keyboard, and we're back to having an unthreaded nut. So let's go ahead and say thread, 1/2 inch, 13, modeled. Let's turn these guys back on. I might have to move the part. Let's go ahead and do an analysis. Yep, I'll have to move it slightly. But let's take a look at the clearance now with these new threads. So you can see, sure enough, we have much better clearance just by recreating those threads. Now, if you needed to, let's say you did a sample print and they were still a little bit snug, you can actually modify your 3D model. So for example, on this nut right here, I could come in and let's just grab maybe this face here. I'm just going to do a press pull, and I can move those faces up a little bit. So you can kind of see how I'm moving them, 0.003, and I now have more clearance. So you can actually use, again, direct modeling techniques to slightly change what you want those threads to look like for that extra clearance. Okay. Hopefully that makes sense with the thread command inside of Fusion, and also using, for example, like a McMaster car part. And like I showed, this works with anything from McMaster car. So I could come in and say, for example, I want a socket head or something like that. So let's do a socket head cap screw, something like this. And again, all of the different sizes in here. Okay. And I could delete those threads off of there. I'm not going to go ahead and do it, but it works for pretty much any of these parts, where I wouldn't want to have to model the head geometry. I could just bring it in and then recreate the threads if necessary. Okay. Okay. So here's a prime example. Here's an object I printed, and I don't know how well it's going to show up on the camera. I apologize. This is actually a pill holder for pills. And so you can kind of like rotate this around, and you can see there's different openings in there and stuff like that. I have to look at my other monitor to see what's going on there. And it's got labels on it, Wednesday, Thursday, Friday, etc. So I'm going to unscrew this, and you can see that I actually 3D printed this. Apologize. So there's the little thumb screw, and it just screws into this little interior post in there. Okay. So how do you go about making sure something like this is going to last? And there's a couple different tips and tricks with this. So the first one I want to talk about is when you print a bolt, you can't really print it sideways, because then you'd have to have support material right here, and that would probably get in the way of the threads and all this kind of stuff. So you typically have to print vertically. Now, unfortunately, when you print vertically, all of the layers are going on like this. And so let me just do a quick example here. I'm going to screw this. I have a sample block. Now, let me zoom up on this. So you can see I've got a couple different sized holes in here. I got a large hole, medium hole, and a small hole right there. And this is what I was talking about, where I'll print a sample block that maybe takes 20 minutes to print or something like that, and make sure that my 3D prints actually screw into there very easily. Okay. If it's too tight, I run the risk of breaking the bolt. So I usually do something like this and print out a couple sample holes and a couple sample bolts first to make sure it's going to work. Now what's neat is I can use even actual machine bolts and screw these in also. So I can see, that would actually screw in and work also instead of using a 3D printed one. So if I'm using real hardware, I will, again, do a sample print, make sure that it fits correctly, and do I need to offset some faces slightly or not? But in this case, it worked perfectly. And again, I used Fusion 360's thread command to do all of these. And I'll be honest, no modification whatsoever on any of these holes, or I didn't have to offset any faces. It's beautiful. You can tell I'm excited about it because I just think it's so nice. But you can kind of see that's definitely in there. Okay. Let me take this guy out. Let's talk about this bolt here. So like I mentioned before, it's printed in layers like this, which unfortunately breaks off really easily because it's layer after layer after layer and it's not very strong. So something like this, I would be really nervous using a 3D printed bolt. I might want to use an actual bolt in this case. Or, and I don't think you're going to be able to see it, but the infill, I didn't do a solid infill. Yeah, it's not going to focus. I apologize. So it's not solid in there. So that also probably helped the fact that it was able to break so easily. So I'm going to show some other options for you. So you can absolutely 3D print the threads and the hole and all that kind of stuff. Another tip with this is when you're printing threads, I recommend printing at a finer resolution. So, for example, 0.1 millimeter layer height instead of 0.2 or whatever you might have yours typically set to. When you're printing threads, you might want to do a tighter, finer resolution on your 3D printing. It just because it's having to do those spiral threads. So that's another tip that I usually do. I increase my layer resolution. Another tip that I usually do is after I've 3D printed, I'll take an actual bolt or screw or whatever and thread that in there to help clean it out. Okay? Instead of using my 3D printed one, which could potentially break, I'll use an actual one that's the right size and thread that in there to help clean it out. Okay? And you can see that goes in very nicely. Another thing I'll do is, I should have had it ready, you can even use an actual tap and die. So this is like what you would use to tap a metal hole, for example. It's got threads on it, and I could stick that in there. I should have it on the handle, but I might run this through and actually clean out my threads using the tap. So especially if I know that I might have to be screwing or unscrewing this particular hole quite a bit, which is exactly what I did on this little 3D printed device that I did. Okay. Same thing with the bolts. You could use a die, a tap and die, and I'll run that through there, and that'll help clean it up. I can't hold it up to the screen, sorry. There we go. And so I'll run that and screw that onto the threads, and that helps clean off any of the little imperfections or there might be on those threads. It just makes it that much cleaner. Okay. I don't think you'll be able to see it, but you can kind of see the change in color where it's gone on and kind of just cleaned off those threads a little bit. So again, it depends on what kind of nuts and bolts you're going to be using. A lot of these are fairly large, obviously. This is probably the smallest one I 3D printed. Now, what if I need to go smaller than that? And this is where you get some options in here. So for example, I have a very small screw in this block right here. And you can see I can actually physically screw it and unscrew it. But there's probably no way I would ever be able to print threads that are that tiny and to be that precise. So if you look inside, there's actually a threaded insert in there. And I use these quite a bit, especially for things like, for example, I do a lot of remote control aircraft flying. I might 3D print a firewall or something for a motor to screw onto. I use these threaded inserts for that, and so I have these small like metric 3 screws that are holding the actual motor to the motor mount. I will use these. So here's a cool little trick. And again, I wish my camera focused a little bit better, but this is kind of what it looks like. Yeah, it's not gonna focus at all. But it's got some kind of sharp threads on it. And then on the inside, it's threaded also. So all you have to do is, one of the ways to do this, let me grab this part here. I'm gonna just start by threading it in. And it won't go any further than that, okay? Then you grab let me turn on my soldering iron. So grab a hot soldering iron. And I don't know how well I'll be able to do this live, but you basically push it into the threaded insert. You just hold it there for a little bit, and now my soldering iron had cooled off. But I'm just pushing down, and as it's going to heat up that metal, you can kind of see it sinking down into my 3D print. And I'm trying to be as level as I can, and then I'll let go. And we've now melted that insert into our 3D printed part. So cool little trick, and now it's permanently in there. So basically it's meshed with the, it's still a little bit soft, so I'm not gonna turn too much, but it's meshed into that 3D plastic. So I use this method quite a bit. I think it's really, really slick. And then the last one is if you don't want to do 3D printed inserts, I'm sorry, these little inserts into your 3D print, you can do what I call a hidden nut. And again, it's kind of hard to see, but there's a little rectangle there, and there's a hole that goes all the way through it. So I could take the very small nut, which let me get here in just a second, like so. So you can see, pretty tiny, right? Well, then I can just put that into that slot. And again, let me try and do this live. Sorry. So I'm going to slide it in there, and it's, again, going to be kind of hard to see, but the nut is now kind of trapped in there. And then I could thread the screw down through the top. And I'm not going to take too much time to do this, but basically, this will thread in, and this gives it that mechanical advantage that it's not going to be able to pull that nut through that plastic. So this is another great way to create a very strong bond, a mechanical bond. Let me see if I can get that screwed in there. And it's as simple as basically drawing a rectangle that's just a little bit wider than the nut. And so you can put the nut in there, and as you turn it, it'll kind of trap that nut in there and keep it from turning, and it gives you that mechanical advantage. So those are a couple tricks that I've personally used. There's probably more out there. Another one I sometimes do, not as often, is if the threads seem a little bit tight, you can sometimes put like some cooking oil or something like that on there as you thread it in, and it just kind of helps lubricate those threads. The last thing I want to show is what if you need to create custom threads. So I'm going to go ahead, let me clean up my desk here a little bit. Let's go ahead and start with a new design. And I'm going to show you how you can create some custom threads. And again, there's probably multiple different ways of doing this. But I'm going to show you just one method that I've used in the past. So I'm going to make this one a little bit larger. Let's do, for example, like a 1-inch diameter. Like so, and I'll go ahead and extrude this, and let's just go maybe 2 inches tall in this case. Okay, so this is pretty much the envelope of the size that I want to create these custom threads. We're going to learn a new command in here called Coil. So I'm going to say create coil. First thing is asking for is which plane or face do you want to draw it on. So I'm going to start down here on the bottom. And then it's asking for a size. So I'm basically going to trace over. So I could type it in or I could just click, and you'll see that I get this interesting result here. Okay. Now I'm going to change the direction of it. Let's see. Let me do that again. Create coil. And I was going to try and set everything to the default here. So usually it's set to revolution and pitch. And then you can kind of see, for example, let me go, I want to, nope, wrong. Try and make it go in the up direction. I did this earlier, but I'm not sure why it's not doing it. Let me see if, no. Come on. There we go. I must not have clicked correctly. Okay, so by default, it's usually set to circular. Okay, and you'll see that we get this red preview going on. And what it's basically doing is it's taking a circular section and it's creating a coil. Now, there's lots of options here, and I was going to kind of walk through each of these. So you'll see, for example, we have revolution and pitch. So I could specify I only want 4 revolutions, and it's only going to go around 4 times. I can also specify the pitch. So for example, I can say minus 0.5, and it's going to set the pitch to be 1/2 inch. If I said, 0.75, it's obviously going to space out that pitch even further. Okay. We also have revolution and height. So I could say, for example, I want 6 revolutions over 2 inches, and it's going to figure out the pitch for me automatically, right? If I said I want 4 revolutions, you can see how it's going to do that, but it's going to keep the height always the same. Okay. Then we have height and pitch, where you can specify what's the height, and then you can specify what's the pitch. And then finally we have spiral, which is just a spiral on a flat plane, which doesn't make sense in this case. So I'm going to do revolution and height in this case. I want 6 revolutions over 2 inches. Then you see we have this section, and right now there's only 4 options in here: circular, square, triangular external, and triangular internal. And you might be saying, well, how are we going to create these custom threads? Well, I kind of cheat. I'm going to go ahead and use, for example, this, we do this triangular external. And if we look really closely, we can see that the point is defining this little edge right here, this spiral edge, which is touching the edge of our part. It's kind of hard to see, but I'm hovering over the spiral edge right now. I'm going to move away. You can kind of really see it spiraling around. Okay. Then we have options for on center, outside. So you're going to see how it's basically taking that profile and starting it on the outside of our cylinder. Or we have on center where it's in the center of it, or we have inside. And this is the one I'm going to use. So basically what it's doing is I'm able to specify how many revolutions, how high do I want that to be, or I could specify, for example, height and pitch. Maybe I'm more concerned about the pitch of my threads, which is what you typically do. So I'm going to come in here and say I want the pitch to be, let's just say minus 0.35 in this case. And you'll notice it's going to change how many revolutions. So if I say 0.5, it's still only going the 2 inches tall, but I now have the different number of revolutions. Okay, so I usually use height and pitch because I'm really concerned about the pitch of my threads. Okay, so I see Jason's asking pop quiz questions. Thanks for doing that. Hopefully this is all making sense to everybody, and thank you for adding your comments and questions in there. So I'm going to go ahead and instead of saying cut, I'm going to make this a new body. And now you can really see the spiral. And if I were to expand open my bodies folder, you'll see that we have this new little spiral part. Okay? If I turn off the spiral, we see we still have the basically the bolt that I want. Now what I'm going to do is create a plane along a path. And now you can see this path that we defined. I'm just going to drag that to the very end because I want to have this plane be tangent to the end of this line. So I just did a construction plane along a path. I've shown this command before in some of my other live streams. I use it a lot. And then I just clicked on the path, and then it allows me to place this plane anywhere I want on that path. So I'm going to put it down here at the very end and say OK. And now I have a part that I can sketch on. So I'm going to say create sketch. And let's just do, I'm going to do kind of a funky profile here. Let's do maybe like a slot. So I'm going to do a center. Let's just do maybe a profile that looks something like this for whatever reason. Okay. So I'm going to turn my body back on, and now you can see that I was able to create basically a spline that goes all the way around my cylinder. I've got my profile on there now, and I can come in and say sweep. Okay, again by default it's usually set to single path. What's my profile? I'll click that as my profile. And then what's my path? I can click on the edge of this body right here. So you can kind of see how I was able to use that triangle to define that. So that's why I like to set it to the inside, because it kind of just creates that for me. Now, for those that are observant, you'll notice an issue here. Fusion's doing exactly what I told it to. I'm telling it to sweep this profile along that spline, but you'll notice as it does that, it's actually physically rotating it. You can kind of see it by the preview that we're getting. It's almost flipping it upside down by the time it gets to the top here. And this is not obviously what I want. I could come in here and say parallel, but that's sometimes doesn't work. So you'll see, sure enough, it couldn't do that. Region of the path is not parallel, so it wouldn't let me do that. So I have to say perpendicular, but it gives me that weird result. Well, here's a neat little tip. If I go under the type, instead of just single path, I'm going to say path and guide surface. So I'm going to click on guide surface, and here's my profile, here's my path, and then the guide surface is going to be the cylinder there. And now you can see how it's going to keep that upright using this blue part basically as the guide. And then the last thing I want to do is I want to make sure I'm only cutting my cylinder. So I'm going to turn off body 2 so it doesn't cut through the other one for me. And let's turn that guy off. And I now have a custom profile that's at the correct pitch, because I was able to specify I wanted 0.375 for my pitch. And so you can create some pretty interesting custom profiles. Okay, that's all I really had for my tips and tricks for 3D printing threads. Just a quick review. I personally recommend, oh actually I forgot to show you one more thing, I apologize. I showed how fragile that one bolt was when I tried threading it, in, and then it just sheared right off because we were printing layer by layer like this. But I told you can't really print, let me get a better bolt here. You can't really print it on the side because you'd have to have support material there. Well, here's a neat little trick. You can actually print a bolt that looks, it's kind of hard to see, let me kind of rotate it around, that it's actually flat, okay? It's only got threads on part of it. There you can kind of see the reflection. So I was able to print this flat on my bed, and the layers are printing in this direction. So, you know, it looks kind of weird, right? But it actually still threads. Let me see if I can do this live without light. Give me just a second there. There we go. So you can see that I'm still able to thread that on there, and it works perfectly, okay? And it's extremely strong. I can't break that. I mean, I could if I had pliers or something like that, but it's extremely strong because of how this was printed. So if you do need a 3D printed bolt for any reason, you could go ahead and do one like this. And it's as simple as basically just machining away what you don't need. So for example, let's just create a really quick sketch on here. And I'm just going to do a rectangle. And again, I'm not doing any measurements or anything like that, just to kind of speed things up. Let's do a line that kind of cuts through here, like so. I'll use that as my mirror line. So I like to select it and turn it to a construction line. And then let's go ahead and mirror those guys along that line right there. We'll say OK. And we can now use these. I need to make sure I'm grabbing all of my profiles. You can see there's still a little curved section there. So I'm clicking and holding to select that profile. We'll say extrude or press pull, doesn't really matter. Do something like this. And I'm going to go symmetric. And so it basically, you know, machined. Oh, and wasn't sharing my screen. Sorry, guys. Let me back up. Oh, the joys of live streaming. Okay, so I just created a rectangle that kind of overlapped the threads a little bit. I drew a horizontal line right here, made that construction, and then mirrored that over, and said finish sketch. Then I just came in and selected my profiles that I want to machine. And again, it's kind of hard to see, but you'll notice that there's a profile right here that's missing. So I'm just going to click and hold for about a second, and I can actually probe through. I'm going to click and hold for about a second. I can probe through and grab that profile, and I'll say extrude, like so. And you can see how it's going to physically flatten that off. And then I'll go ahead and do the same thing. I'll just say symmetric, say OK. And of course, these are two, you know, a nut and a bolt, but hopefully you get the idea. Now I could 3D print this flat. And there's still enough geometry here for it to print the threads on both sides. And it's going to create that particular shaped bolt that I showed earlier, like so. And this totally works. So definitely recommend doing that if you can. It looks a little bit different, but it does work. So anyways, I apologize for that little hiccup there. Hopefully these tips and tricks were useful for you. If you have any questions or comments, please add them into the Q&A section, or the chat section, I should say, or into the comments. Make sure you thumbs up, thumbs down, add comments, and hope to see you on our 4-part series that's coming up. Definitely keep an eye out on that webpage that I showed you for all of our upcoming live streams. And with that, I hope you have a wonderful rest of your day. Thank you.